Okay guys, I'm a teacher Limboka Sajuga Masame. Welcome to Limboka Physics. We have a question below from SERWAY&JEWETT. The question 59, chapter 35. Okay. We've given the vertical poles. It is 4 meters long. The sun rays from the sun parallels and the incident on the surface of the lake at an angle of 40 degrees is horizontal. Sorry, don't know. Okay. It determines the length of the pole shadows on the bottom of the lake. Okay. I just use graphical methods to get an answer, and I just use two concepts here. I just use reflections and refractions, especially for the case of pulse image on the surface of water, and for the case of the shadows I use that as a concept of refractions, because shadows formed due to some rays from the sun that blocked by the opaque object. Now the pole acts as the opaque object, and it blocks several rays and allow only one rays from the head to hit the surface of water at point D and get refracted down to point A dash. Yeah, this is point A dash because this head top of the pole will be taken down from these poles, and this C. Now the shadow is this place, then this is 40, it measures 40 degrees, then the remaining is 50. From the calculations below, so you can see it is just the refracted rays is 35.1 degrees. For the purpose of the graphical methods, we just assume it is approximately equal to 35 degrees, where just 1 meter represents 1 centimeter, and it becomes as you can see here. Okay. And for another case, when we measure distance A dash to C is equal to 3.8 centimeter. When we use another method, is that one where we use to to get the image of the poles as a result of refractions from the surface of the water to the bottoms, and a little bit reflections. The first ray on the surface A is incident here on the surface of water and refracted at this point, and then reflected up and emerging at this point where our eyes of the observer is observing. Okay. And another ray is incident at a point B. I just I try to name the point B and point C so that we can see how the image formed. That's why here I put the A dash, so that this is the visual image due to refraction, and the second part also will form its image due to refraction at this point. And remember, this is the refracted rays. Purple represents the refracted angle, that is 35 degrees, while the yellow one, the orange or yellow one, represent the incident angle, and this black one represents the angle with the horizontal with these parallel rays from the sun. Okay, this is the refracted. Then must make sure that this angle is the same as this one. This is reflected, and the part B is its image formed at this point where the normal intersect with this extended backwards refracted ray. Okay, and also this normal rays incidents intersect at this point with extended refracted rays, and part B is here. Part C is formed as rays from the point C that incidence on the surface of the water is refracted away from this normal, and remember, this incidence must be the angle for refractions, this one, and also this must be angle of refraction, that is 35 degrees. Then if we take a ruler and measure the distance C to aid of this distance from here to this point, and then we get 3.8 centimeter 2. Okay, by using either because we asked it to find the shadow, the length of the shadow, this is the shadow, and this is just an image. Once when you are take a view on the surface of the pool or lake, whatever the water body is, you'll see your own image that is very rough and gets its motions with that of the fluid, the water. If the water is moved in either ways, also image is swinging in such directions. Okay, we just use measurement methods, and here is just calculation method, and then we just assure that there is no total internal reflection. That's why we find the critical angle, and therefore there is no any total internal reflection. The rays will suffer inside the water while it is emerging out of the water. Okay, and then we use simple mathematics for tan error, then for tan of 40 degrees for this part and for this part, so that we will have a distance, as you can see here mathematically, this is equal to 3.79 meter. Okay, also for some calculation also from here, all you arrive at this answer. Okay, the calculated method is approximately equal to the graphical method. Thanks for watching. Like, share, comments. Don't forget to subscribe to this channel for more video. Thank you.